Assalamualaikum and hi, my name is Syahida Maamor. So, I'm presenting for EAT 208 Electrical Power Technology project, which is this is a three-phase transformer project. So we start with introduction of three-phase transformer. Okay, three-phase transformer is can be constructed in two ways, which is single-phase transformers, and single-phase transformer consists of three windings. And for three-phase transformer, it has four possible connections, which is Y to Y, Y to delta connection, delta to delta connection, and delta to Y connection. So, however, in this project, we are focused on the Y to Y connection. The objective of this experiment is to evaluate the parameters of the three-phase system. Next, to understand the significance of the phase sequence for the generated voltages of a three-phase system in Y-Y connection. And last one is to calculate the active power absorbed by the loads using 2 watt-meter method and the conventional measuring method. Now, let's take a look at the parameter given. So for my project, the voltage line given is 33 kilovolt, and according to the electricity supply application handbook, for voltage 132 kilovolt and below than that, the power factor is equals to 0.85. So I'm using the power factor to find the V load and the I phase for the circuit. Yeah, now let's proceed to the discussion of this project. From the circuit shown here, this is the generator side and this is the transmission load side. So this is the Y to Y connection. So the value here is from the our metric card number, and so this is the value of the impedance and the voltage here. So the given voltage line is 33 kilovolt, and from the given voltage line we can find the V phase. Okay, so since the Z1 equals to Z2 and equals to Z3, so this is a balanced condition. So when we calculate I line at the transmission load, we will get the same value of the I line since the condition is balanced. Okay, now since we know that the circuit is in balanced condition, so the I phase also equals to the I line. So we can directly take the value of I line equals to the I phase, and we don't need to calculate for the I phase value. Next, for V load, we know that we can use the Ohm's law. So V load equals to I line times the load, which is Z. So in this condition, in this balanced condition, we know that the value of I lines is same for the three phase and also the value load. So we can directly assume that the V load A equals to V load B and equals to V load C, and we get the same answer for the V load. So actually for this project, the main question that they want us to find is the voltage drop for the circuit. Since the power factor is equals to 0.85, as I mentioned that I got from the electricity supply application handbook. So since my V line also below than 132 kilovolt, so I need to use the power factor equals to 0.85. So I can get the phase, the degree equals to 31. 0.79 degree. Okay, now we want to calculate the active power using 2 watt meter method and conventional measuring method. So the difference between these two methods is for 2 watt meter method, we use the V line and I line. And for conventional measuring method, we use the V phase and I phase. So for 2 watt meter method, it is named 2 watt meter because if we want to calculate the active power, we need to find the power at the first winding, which is P1, and the power at the second winding, which is P2. So from this value, you get the P1 and P2. So, okay, here. So this is the value of the 2 watt meter method, and this for conventional measurement method, we use the V phase and I phase. So we get the same value of the active power, even though we use the um, different parameters, which is I line, V line, and V phase, I phase. Based on the experiment, a balanced condition of circuit must have equal a value of I line. And for voltage drop is the voltage loss that occurs through all of the circuit due to the impedance. So if we have larger load, means the resistance is will increase. So that's why our voltage drop will also have the high value here. So if we want to control our voltage drop, we need to control we need to lower the impedance value. So that's mean we need to put a lower value of load in our transformer. Okay, now let's take a look at the simulation. So where's the simulation? Okay, now let's take a look at the simulation. So we want to look at the value of I1, I2, and I3. This is equals to the I line. So since as I said just now, the circuit is in balanced condition. So the value of the current and voltage should be same. So let's take a look. So first, I1 2.122 S12, I2 also 2.122, and I3 also 2.122 S1 and 2. So in average, if you calculate the average of the uh, line current, it should get the same, which is 2.12 or 2.13 in average for the line current. Okay, next, let's take a look at the next value, which is VAB, VBC, and VCA. Okay, all of this value also should be same. This first VAB, VBC, and VCA. Okay, so the average is maybe 2.99 as 0.4 in average. And next, the value for V load. So as we calculate just now, the V load is V load 1 equals to V load B equals to V load C, since we have the same I line and the load. So same with the simulation, you also get the same value of the V load A, B and C. Okay, next. The next one is, sorry, the value of V phase. Okay, so V phase also have the same value. First V phase 1 2.68 exponent 4, V phase 2 also 2.68 exponent 4, and also same for V phase 3 2.69. Just in average, all of the V phase equals to 2.69 exponent 4 volt. Okay, that's for the simulation. In conclusion, we can say that three-phase system is a way much better than the single-phase system. This is because if we look at the some aspect, such as rating, the three-phase system has a higher rating than the single-phase system, which is 1.5 times the rating of a single phase. And next, the constant power in single phase also keep pulsating, and even when the voltage and current are in phase, the power is zero twice in each cycle. Where however, in the three-phase system, the power delivered is almost constant when the loads are in balance condition, as we can see in our delta, in our YY circuit just now. The active power is same. And next, the three-phase system also require only 75% of the weight of conducting material of that required by single-phase system to transmit the same amount of power over a fixed distance of a given voltage. Next, the power factor also important to the value of the phase. So that's why we need to follow the electricity supply application handbook in order to get the correct value before we come up with any experiment. Okay, last but not least, all of the objectives of this experiment have been obtained successfully according to the uh, experiment and the simulation. That's all from me. Thank you.